Alright, given the functions above, what's the value of f of g of 3? Alright, f of g of 3 really just means take the results of this and plug it into this formula. So we'll start with g of 3, x squared minus 3 squared minus 3, because we're taking the 3 here and putting it everywhere you see an x. 9 minus 3 is 6. So then we want to know f of 6. So 8 times 6, because we have the x here, 6 minus, this is times. So 6 times 8 is 48, minus 6 is 42. Points x and y are on a circle with center O. We have this, O, x, and y. And z is on the longer arc, so since we have this point and this point, we have the short arc, and we have the longer arc. So z will be somewhere over here, perhaps. If the measure of angle XOY, so this angle here, is 135, and the length of arc is what fraction of the circumference? So xzy here, okay? Alright, so if this is 135, 360 minus 135 is going to be the angle on this side here. Right? This is what we're trying to find at the moment. So here, 5, 2, 2. Yeah. So 225. What fraction of the circumference of the circle is this length here? Well, it is going to be 225 over 360 times the circumference. Okay, because we have 360 all the way around. The arc we're talking about is 225 of that, so it's going to be this fraction here. Okay, so 225 divided by 360. It's going to be 0.625. So 0.625, which I believe is 5/8. Alright, so this is actually my third take on trying to do this problem nicely, but I've already screwed it up twice. Hopefully this time I'll do a little better. But I mentioned that just to reassure you that this problem can be a little tricky. Alright, so here they give you the problem, and I see this a squared b squared, and then I see another squared over here, and to me that really feels like quadratic. So if I were to take ab plus 1 over ab and multiply it again times ab over 1 plus ab, I get my a squared b squared, and I get my 1 over a squared b squared. Right? Because if you take the left side here times that, you get a squared b squared, and so on. But you also get 1 over ab times ab twice, right? Because it's once for this combination and then once for this other combination. Now you'll notice that the ab here cancels out. So, okay, also here this is equal to 4, and this is also equal to 4, which means that this here is 16. Okay, so a squared b squared plus 1 over a squared b squared, right? So I'm taking this one and this one, plus 2 equals 16, which means that the final answer is 14, because I subtract from both sides, because the 2 from both sides, right, to cancel that. And this here is what they're asking about in this problem. In the triangle TUV, what is the length of TS? So they want to know what is this. Right, so this here, 60 This here also needs to be 60. That's not true. Doesn't have to be. That does not have to be 60. But still, this is a 30, 60, 90 triangle, which we know because we have a right angle here. We have a 30 and a 60. They want to know what's up here. Okay, so if we have a 30, 60, 90 triangle, this will be half of this, which means that this up here will be 10. If absolute value of minus 3x plus 5 is less than 6, what's one possible value of x? If x must be a positive integer, positive odd integer. Okay, so if we have 3x minus 3x plus 5 is less than 6, and we also have minus 1 times minus 3x plus 5 is less than 6. So here we're going to have 3x minus 5 is less than 6. So let's put 6 by itself. Minus 3x is less than, you bring the 5 over here, 1. So x is going to be greater than 1/3. Okay, we have to flip the less than here because we're dividing by a negative number. Here we have 3x is less than 6 plus 5, which is 11. X has to be less than 11/3, which is 3 plus some fraction, something over 3, 2/3, 2/3. Okay, so x has to be greater than 1/3 and less than 3 2/3. They want an odd integer, which means that it could be either 1 or 3. Right? It has to be greater than this and has to be less than that 3. So this is the answer. During a dance class, each of the 12 students is paired up with each of the other students twice. How many total pairings will there be during the class? Well, that would be, if you take the first person, so each one will, think of it like picking teams. Each person is able to pick teams, and then once you have a person, each one of them can have 11 choices. Okay, so 11 times 12 is 131, if I remember correctly. Okay, now, how is paired up with each of the students twice. So what that means is you don't have to, each of the students is paired up twice, which really is the same thing as this 131 here, because say that you have person A is a person that is picking teams, and then they pick B. Okay. At some point, you're also going to have B picking teams, and they're going to pick A. Right? And all of those are accounted for in here. The median of a set of 55 consecutive odd integers is 55. What is the greatest of these integers? So if we have the median is 55, okay, and there are 55 of them, so we have 1, 53, 57, 2, 3. Then we have 51 and 59, right? So now we have, we've now used 1, 2, 3, 4, 5 numbers, okay? So if we try to generate a formula from this, we're going to have the greatest of these integers is going to be 55 plus the number of integers minus 1. Right? 5 minus 1 is 4. 55 plus 4 is 59. Okay, so 55 plus 55 minus 1 means that we have 1 110. In the shaded region above, if the shaded region above has a perimeter of 24 plus 2 square root of 2 units, what is the area of the inscribed circle? Okay, so they're saying the perimeter of the shaded region, this right here is the shaded region. So really this plus this plus this plus that plus that plus that, all of that together is this number here. Okay, now we have a circle here, which means that's why b here is equal to this, b is equal to that, is equal to that. And also we have a square here, or a perpendicular angle, which really means that these here have to be 45. Well, plus also they have the same side on each side. Okay, so we know that a 2a plus 4b equals 24 plus 12 square root of 2. Okay, so how can we relate a and b? A to b. This is a 45, 45, 90 triangle. Okay, so that means, well, if you don't remember the formula, as it's escaping me at the moment, I happen to know that b squared plus b squared equals a squared. Okay, so because it's the Pythagorean theorem, b squared plus b squared is a squared. So I have 2b squared equals a squared. Square root both sides, I have square root of 2. b equals a. Okay, so let's take that back up here, so that we will solve for b, because we're going to need to have b, because we need to do pi r squared, and the radius is b. So if I want 4b equals 24 plus 12 square root of 2 minus 2a, actually, scratch that, 2a. 2a I happen to know is square root of 2b, so 2 square root of 2b plus, forgot the plus here, plus 4b equals all of this. Okay, so 2 square root of 2 plus 4 all times b equals 12 square root of 2 plus 24. If I were to take 6 out of this, I have 6 times 2 square root of 2 plus 4, which is this. I end up, if I divide both sides by this part here, I end up with b equals 6. Okay, because I can then, if I divide all of this side by this, then this here just cancels, b equals 6. So now the area is pi 6 squared, so 36